There we go. So good evening, everyone. Welcome to the May edition of DC604 Meetup. Today we have a CTF workshop based on CDon't CTF. It's a public CTF. You can deploy it into your own AWS account. So you'll have your own lab running in your account. That lab is limited to or restricted to the IP address from which you've done the deployment. So basically the machine that you're going to be using to walk through the labs, deploy it from that machine. Otherwise you would need to go in and update the security groups and add additional IP addresses, etc. But that also means that because this is sorry, what was that? Okay, maybe nothing. Yeah, so mute yourself if you're not talking, so we don't have any noise. But if you have a question, feel free to unmute or post in chat, and we'll go from there. But yeah, so that IP restriction essentially means that the CTF lab is intentionally vulnerable environment, so you probably don't want that exposed to the internet. But that IP address limitation essentially means that only you can access the lab. All right. Once you've deployed the lab, there's important information that Terraform will output at the end. So there's several things. One is the target IP, and this is the IP address of that target GitLab instance. So the whole CTF is based on GitLab. And so this is basically where you'll be logging in and exploring, etc. The attack box is kind of a utility box, if you will. If you don't have a machine with a public IP address, you can use this attack box for any sort of catching reverse shells and doing things like that. It will also give you credentials. So the username is based on the username that you've entered as part of the deployment, and then the password is a randomly generated password that you can use for both SSH access to the attack box, but also for logging into the GitLab. So what I'm going to do to make my life easier is okay. Yeah, so I'm just going to copy my SSH key into that machine just so that it's easier for me to connect. So that's all I'm doing for now. And see if it works. All right, so save this. If you didn't save it, I think you can do Terraform show. I might need help with this. Yeah, if you do Terraform show, it will display that information again. If you need to get it back, that password is randomly generated. The username you've entered and IP address are obviously random, just based on the deployed resources. All right, and so basically, essentially, what we have is the CTF based on, like, we're exploring security of CI/CD pipelines. The CTF is based on GitLab, which is a popular version control and CI/CD tool. So it's kind of all-in-one system that is quite popular among developers and tech companies. And basically, let's get to the objective. So the objective of the CTF is gain access to this AWS_admin_automation_user through whatever means necessary. That role actually, this is more FYI, that role actually doesn't have, or that ID doesn't have any permissions within AWS. It's just sort of the objective. There are keys and access keys associated with the ID, but there's no permissions attached to the ID. So that's the goal. And first thing we'll do is just log in to GitLab and see what's happening here. So I'll use that airman as my ID and the password that I got. All right. And before we go any further, a couple things that I want to sort of mention to set the context. So as I said, GitLab is essentially a combination of a number of tools. So it has a ticketing system, so you can basically create tickets for new features or defects, et cetera, and sort of manage the workflow in there. It's a version control system. It's basically Git-based, so it's a web UI wrapped around Git, sort of like GitHub. And it's also a CI/CD tool, so it allows you to build CI/CD pipelines, basically defined automated processes, how your code, how your application, how your software is being built, and it also can deploy that software into different environments. And as I can't remember who said this is not my saying, but essentially what CI/CD tools are is code execution as a service, because this is what they do. Majority of them will allow you to define custom commands for your build and deploy stages. And basically it's not a trivial task to secure that environment, especially in a sort of cloud-based service where you have you're running this as a public service, and you've got a bunch of people defining those pipelines and then running those pipelines and basically preventing any sort of malicious activity in those pipelines is not a trivial task. There's a whole bunch of different CI/CD tools that are available. So there's Jenkins, it's more sort of traditional on-prem type tool, and there's a bunch of them that are sort of cloud-based. But there's Jenkins, there's Travis CI, Circle CI, Github Actions. So GitHub is sort of a interface for Git, but also they've implemented, I don't think it happened long ago, but basically they have GitHub Actions, which essentially is a CI/CD tool within hosted CI/CD tool within GitHub. There's also Azure DevOps, there's AWS Code Build, there's Flask and Bamboo, there's a whole bunch of them. And they're all slightly different, but they're all kind of geared towards the same thing, which is allow you to define those automated processes for firstly, building software, running some automated tests on that software, as well as deploying software into either production or any other sort of development environment, etc. So today we're dealing with GitLab, but it could have been theoretically any of those other tools. Now, as we've read, our objective is to grab those, to gain access to those AWS credentials. So why do we have credentials in the CI/CD tools? We have credentials because of that second, the CD part, the continuous deployment, meaning that often these are used for automated deployment process as well, and to do any sort of deployments into your cloud environments, or even if it's not cloud, but you still need to have fairly privileged credentials to be able to log into AWS and provision the resources that your application needs, or update versions of the software and do things like that. So CI/CD tools in general are fairly juicy targets for attackers, and partially because they tend to contain those very privileged credentials that give access to mostly cloud environments, but it could be not necessarily be cloud. It could be some sort of VMware type thing. Okay, I'm gonna quickly check if there's questions. Yeah, so Sashimi, it takes a little bit of time after Terraform is done. There's still scripts that are running in the background and provisioning content within GitLab. So it takes about 10 to 12 minutes after Terraform is complete for the provisioning to finish. The way you can see if it's done or not, if you on the login page, if you see the Softhouse IO at the front page, then it's done. If you don't see that, then it's still doing something. Okay, I'm gonna log back in. All right, so now we've talked about CI/CD. So I'm gonna take a pause for 5, maybe 10 minutes and let all of you explore that GitLab instance and then reconvene and talk about what we saw. So if anybody needs help with the setup or have any questions, or if you find something juicy, post in the chat. But I'll just start a timer for, maybe let's start with 5 minutes, and then we can sort of start discussion around what people found in the instance. And I'm going to check if there's any more questions meanwhile. Guess I'm still muted. So Telash was posting, if you're trying to run Terraform on newer M1 Macs, there's some quirk that needs to be fixed. It doesn't work out of the box. So if you're having issues, just post in chat and somebody will help you out. All right. So sounds like Sashimi is still having issues logging in. I hope most of the people were able to stand up the GitLab and log in and look around. So what I think we should try to do is basically see what interesting things we found. So if you found something interesting or something that's worth looking at, just post in the chat. Or maybe we can even enable unmuting for a bit. All right. So share what you found. Okay, so Mark found that admin IAM credentials are being stored in environment variables in this project. And what project was that? Infra Deployer. So when I log in, I only see this project, and that's, I think, because I've been added to the project as contributor. So I can basically change files within that repository. But there are other projects in this instance. So if I go into explore projects, I can see quite a lot of them. And one looks quite interesting, and it's different Mark, I guess, who created it. One looks interesting just from the name perspective. It's called Infra Deployer. And so as we talked about CICD and the fact that they have credentials and the deployment part usually has credentials, this probably is the project that we need to get into to get those credentials. When we come here, it does mention that there's admin IAM credentials that are being stored in environment variables in this project and to be used with the GitLab runners. So runners are essentially, the concept of runners is very closely related to the whole idea of CI/CD. It's basically something where the CI/CD pipelines are being executed. They often can be either VMs or containers, and it's basically a blank canvas that will copy or clone your pipeline or instructions from your pipeline and then execute those instructions. And those instructions can be, for example, they often start with clone this project that I'm going to build and then do something afterwards. So runner essentially is either machine, VM, or a container where those commands are actually being executed. And so those runners for the CD part, as we talked about, will need credentials to do the deployment. And those credentials are often provided as environment variables. So you basically define those secrets somewhere in the tool, in the CI/CD tool, and then they're injected at runtime as environment variables. So within your commands that do the deployments, you can use those environment variables and use those credentials. So this is very well aligned with what we would expect. And this basically gives us an idea that probably this is the target project that we need to get into. If you try to actually do something in this project, like add a file or change this README, you will find you won't be able to. So if you click on the edit, it will actually create a copy of that project that you own and edit, or will create a commit in that clone, but not in the original project. Another thing that, or maybe we'll talk about this later on, where those credentials are, or maybe we can talk about that now. So if I go back to your projects and go into the project that we do have access to, now I need to recall where that's defined. I guess not here. Okay, so there's settings and access tokens. These access tokens are not access tokens that we're interested in. This is access tokens for access to the GitLab project. The credentials that we're interested in are related to CI/CD. So if we go into settings and then CI/CD and go into variables, this is where those keys will appear. So the project that we do have access to, there's no secrets, no keys, or no credentials defined. So it's basically empty. But if we go to that other project, we will see that we actually don't have access to the project. It's basically read-only access. And with the access that we do have, we're not able to go into the settings and check those variables, which makes sense. All right. Anything else interesting that anybody was able to find? Come on, there must be something. Okay, Karen, that's a good idea. So we should probably look at the issues in the side menu. So we do have access to this project. Let's take a look at the issues. We see that there's 2 issues, and this is basically those tickets that can be raised and managed within the project. So we can go into issues and see what those issues are. Does the shared runners mean that you can use the runners you have access to run the Infra Deployer? So usually what's happening, Talish, is when the runner starts a new job, it's either it's basically reverted to blank state. So there's no artifacts usually left on the runner between executions of the same pipeline, and definitely between the executions of the different pipelines. So if your question was more along the lines of can we basically access the runner and see if there's anything from that Infra Deployer project, then the answer is likely no, and unless there's like a bug or vulnerability in the CI/CD tool. Did I understand your question correctly? Okay. But keep that thought, because one thing I want to talk about a little bit is, so as I said, those runners, one of the first steps that they usually do is check out your code, because this is the code, this is the source code that they need to build, they need access to. And so from that perspective, there's usually tokens that have access to repositories that are automatically injected into the runner, so they can do a checkout and basically interact with the GitLab or the version control system itself and do things. So we'll check those credentials. There's some credentials in the runner that we'll see in just a bit. So again, if you've got questions or if you found something interesting, post in chat, but we're going to explore these issues now as Kevin suggested. So we've got 2. One looks like it's sort of a ironical one. Should we port this to Rust? And then a whole bunch of discussion there. Rust must be really hot with developers lately. And by the way, definitely security people really found interesting applications of Rust from what I've seen. So this other one is much more interesting because it says, hey, when you get a chance, can you take a look at our CICD config? Something is going on with it. I was trying to build a new Docker container, but it wasn't working right. And this is definitely a hint. So it's kind of pointing us in the direction of where we want to look next. So from this, we can go back to the repository and check that there is indeed that CICD configuration. So this is CICD configuration, basically those steps that define how the code is built and deployed is often stored in the version control system itself. How it's being done, it depends on what CICD tool you use. So For GitLab specifically, you basically create a file called .gitlab-ci.yml. It's a YAML file that defines those steps, and basically GitLab automatically parses that file and uses that as the definition of the pipeline. So if we go into CI/CD here, we can see that there's jobs. Well, I guess not. Maybe that's because those jobs have not been executed yet. But if we go to editor and it brings up this definition of the pipeline, this is essentially the same thing as if I went into just repository and took a look at that YAML file. This is basically the same thing. So we can, this is sort of slightly more convenient interface. So let's take a look at this, because this is definitely interesting, and we've been pointed to it. So you see that there's a couple stages. So this build job and deploy prod are two steps that are defined as part of this CI/CD pipeline. And I put CI/CD in quotes because it actually doesn't do anything apart from outputting some basically text. But you see that GitLab has this idea of stages. So it basically, the stages could be like build, deploy, et cetera, et cetera. I don't actually know the full list, but in this case, in the case of GitLab, these stages are predefined. So you cannot just put any string in here, like the name of the stage should match the kind of the stage definition within GitLab. But then there's multiple ways to define those steps. And one of the ways is just to provide commands to run in the runner. So in this case, we have a script that does the echo whatever, and we actually can modify it and also do, let's run env, because a lot of things, as I said, are injected as environment variables into the runner. So this will at least give us a slight idea about what we can expect in there. So now, as we're changing this file, because it's part of that source code repository, we need to commit it. It's basically, we're creating a new commit with an updated file, and usually that kicks off the CI/CD pipeline. In majority of the tools, you can define those events that trigger CI/CD. You might want to do those builds or deployments from like pull requests or commits, or only commits to certain branches, but not all the branches. So you usually have a lot of flexibility, but generally those pipelines are triggered by some sort of commit. There might be restrictions on what commits do trigger the pipeline, but it's generally commit-based triggers. So in this case, I think that's because there's no triggers defined. It kind of uses the default trigger, which starts the pipeline for any commit into the main branch of that repository. So commit message will just use default, branch will use default, main, do commit changes and see what happens. Okay, so when we committed changes, there was this pipeline created from this file, from this commit, and we see that the pipeline is running. So we can click on it and see what's happening. I think it's actually in the jobs. Okay. So this is the jobs. You remember there was like two steps in that pipeline. So this kind of line items are corresponding to those steps. So first was the build job, so we can see what was happening here, and this is where we've added our command. So we see that there's it basically wrote what command it's executing and then the output of that command, and then this is the command that we've added, and we see there's a whole bunch of environment variables that are injected in here. And I want to point out a couple things in here. So firstly, always environment variables are definitely interesting things to check. So firstly, I'd like to point out that there's a couple really interesting environment variables. So one is called CI registry user. So we see the CI registry user, and also there's a CI registry password, which is masked. So this is that automatically injected user ID that can interact with the version control system and like check out code from that project and do things like that. So firstly, there's credentials in there. Even if you don't inject credentials, GitLab for its inner workings will inject some credentials. What's important is, and you can, by the way, test this, and I did, by the way, as part of my exploration of this CTF, you can test what projects this user ID has access to. I don't know if it's configured, but the way this CTF is deployed, it has read access to all of the projects. So you actually can use it to check out that Infra Deployer project. By the way, when you check out the project, those secrets, that they are not part of the source code. So it's basically metadata of the project. So you cannot get access to them just by checking out the project. The second important piece is this mask piece. So secrets can be, those environment variables or secrets can be marked as secrets, which essentially means that whenever GitLab watches all the output of the build steps within your pipeline, and if it encounters any of the variables, values of the variables that have been marked as secret, it will replace those with this masked in brackets string. That way it's kind of harder to leak, accidentally leak those credentials that you have marked as secret. And so it's doing that for the default token by default. So another thing I'd like to highlight with this is more of a sort of a safety net, or this prevents you from accidentally disclosing those secrets. It doesn't prevent somebody who actually has access to the project from leaking those secrets. And the reason I'm saying this is that masking is fairly straightforward. It basically looks for a string match of any defined secrets within the output of any of the commands. And if there is a match, that's what's being replaced. So if, for example, we did, we piped output of env into, and base64 encoded it, because there's no one-to-one string match. If we grab that output, then, and base64 decode it, then we can get access to those secrets. So let's do that and see if I'm right. And I'm almost 100% certain. In which location was the secret injected? So the secrets are injected as environment variables. So when the runner starts and starts to execute the commands within the pipeline, the environment variables within that shell environment will contain all of those secrets. So that output that you saw is the output of the env command, which basically lists all of the operating system environment variables. So we see this was our second run, and we can check the output. And now we have a bunch of base64. And if I can just grab this and base64 code. I don't know what's happening, but I basically piped this to base64-d. And if I scroll up, and I forgot already again what was the name of that. So here's that CI registry password that was masked previously, but now it's not masked because it wasn't like one-to-one mapping in that output, so it wasn't masked.
So let's just unpack that. So what you're saying is, because there was not a value for these parameters, like in this case, CI_registry password, it just outputted this, well, and the fact that we told it to output it as base64, there was a big blob. So as a result, it wasn't able to mask it because it was like, well, I don't know what that is.
Yeah, exactly.
It's just a blob of data. Oh, that's a very interesting workflow.
Yeah, exactly. There's another important thing that I wanted to mention with regard to this, and again, this is based on some testing that I've done. Those credentials that are injected by default, at least in GitLab, and it's probably true for other CI/CD tools as well, they are only valid for the time when that job is being executed. So although I have the credentials right now, because the pipeline job have stopped, it's already done, I can no longer use these credentials to do anything, even like check out the source code. They're invalidated right after the pipeline finishes. But if I inject a command that will give me a reverse shell, because it's usually done in a way that it's kind of hanging in there and it's like waiting for your input and executing your commands, but not finishing, the process doesn't exit, those credentials will be valid for the duration of that reverse shell. So it's kind of an important and I think interesting fact to know. All right. Any other thoughts or questions or suggestions with regard to what we can do or should do? Today I learned the term reverse shell. Do we need to talk about that? I'm happy to, because we'll be getting a reverse shell as our next step. And so if we need to explain what that is, why we're interested in it, I'm happy to go through that as well. And I'm just checking my notes to make sure that I didn't miss anything.
And just a reminder, folks can unmute themselves now if they want to.
Yep, yep. Okay, cool. So we've checked the Infra Deployer, we've checked the MVP Docker, we've checked the CI/CD the workflow definition. We ran it. Okay, one more thing that I'd like to mention, or maybe there's questions or comments, or something else we can check. Okay, so what I wanted to highlight is this part of that ticket. I was trying to build our new Docker container. And the reason this is important, and we'll get to it in just a bit, and we'll actually use this. So runners in Gitlab are executed as containers. So as I said, some like different tools do this differently. For example, I know GitHub is spinning up VMs and using those as runners, like they're not doing containers as runners. But in Gitlab, containers are used as runners, meaning that, for example, you can have a single VM that can be executing multiple runners as containers and potentially at the same time without them interfering with each other and without any sort of crazy sort of snapshotting and VM provisioning, deprovisioning, that kind of thing. So this part is very interesting, because if the fact that Ashley is mentioning building Docker containers generally means that to build a Docker container, you generally need access to the Docker daemon, because it's the daemon. There's tools that can do container building without that, but they're not as widely used. So like traditionally, if you do Docker build, the Docker build command needs to be able to call into the Docker API and communicate with the Docker daemon. And that access, if you read Docker's documentation, essentially access to Docker daemon means privileged access to the host. And we'll get back to that in just a bit, but that's an important tidbit that I just want to point out for now. Kevin is saying, one thing that I was surprised at when working with the CI/CD Docker instance is how little is installed in the container. That's true, and that's the whole idea behind containers. If you do containers right, they will only contain the application. Like traditionally, containers are used for packaging applications. And the idea is that you will package everything that your application needs, but nothing else. And so that does two things. Firstly, smaller containers start faster. But secondly, as a security professional, the less tools you have in that container, the harder it is to basically do lateral movement or any sort of privilege escalation from that container if an attacker were to compromise the container. So we'll get to that as well, but that's generally true for containers. All right. Any other comments or questions? Okay. One more thing that I'll mention, and I'll post a link here, link in here as well in just a bit. I just realized I don't have a video on yet or anymore, so I'll fix that. So to get the reverse shell, where am I typing this? Pen test monkey. I'm going to search for pentest monkey reverse shell. This is a blog post that contains quite a lot of different ways of getting reverse shells. I use it all the time because I can never remember any of these commands. But basically, what all of them do is they start a new shell, usually bash, and they will initiate a connection back into the IP that you can provide as part of the command, and basically allow you to interact with that shell. That's essentially what reverse shell is. And reverse part is convenient because you don't need to, you're not relying on like firewall ports being open for you to be able to connect into that box that you can run commands on. And basically that box is connecting back to you, and you can generally, if there's no egress firewall controls in that environment, you can control the firewalls on your side and kind of accept that reverse shell. So it's generally easier to get a reverse shell than it is to get a sort of regular forward shell or bind shell. So I'm going to use this first one because I know it works. And so let's firstly talk a little bit how, like, what it means, what all these commands do, and then we'll just supply our IP address, and that's not the right one. Okay, so I wanted to SSH into my attack box. If I can remember the IP, just give me a sec. I need to prep for this. So I'm going to SSH the attack box. And the attack box was given to us for this exact reason. So we don't need yet another box that can accept those reverse shells. Oops, not root. So SSH here doesn't ask for my password because earlier I've installed an SSH key. Yeah, thanks, Sashimi. So this is on my attack box. So what we're gonna do is I'm gonna go back to that pipeline editor, and we're gonna replace our env command with this reverse shell command. Okay. By the way, do we need to talk about sort of basics of YAML syntax, or does all of this make sense? Post in chat if you want me to talk a little bit about YAML. Okay, James wants me to talk about YAML. So sure, so YAML is basically a fairly simple format that allows you to define data structures. It's very similar to JSON in sort of idea, essentially meaning that it can define the same types of data structures, and it's also text-based, but it's a little bit easier to read for people and easier to write for people, because JSON can get somewhat complicated with all of those curly braces and whatnot. So what essentially is happening is basically YAML uses indentation to for nesting. So what's happening here is we're saying, okay, here's the field, or you can think of it as variable that's called build job. And that variable, think of that as sort of object. And that object has another variable that's called stage. And this is the value of that variable, which is basically string. So this is kind of a dictionary. So it can be like the name of the field or name of the variable, and then it can either get a value itself, or if there's indentation, it essentially means that it's a sort of complex object that has multiple sort of variables defined. And so this is build job is the top level field that has stage as the nested field. This is the value of the field. And there's one more thing to remember, which is these dashes in front, and dashes in front essentially means it's an array. So when you look at this, script is an array, and this is the first string in the array, and this is the second string in that array. Yeah, so not all of the indented data is array, but when there's a the dash in the beginning, that's denoting array. Otherwise, you can think of it as dictionary, or basically like this is the name of the field. And so that's all there is to it. YAML and JSON are easily convertible into one another. YAML formally supports JSON syntax. So instead of this, for example, you can write, so I'll leave this so we don't break stuff. But instead of that script with the dashes and whatnot, you can write, for example, this script and then do like string 1, string 2. And this is essentially the same thing as doing this string 1 and then string 2. So those two things are the same. Okay. Hopefully that makes sense, James. If we need to cover it a little bit more, let me know. So let's see what's happening here. So we're basically starting bash in interactive mode. I think that's what the -I means. And then we're doing some fancy redirect. So firstly, we're redirecting the output into this special device. And what this is a Linux thing. So this special device, essentially the dev TCP is the special device. And after that dev TCP, you can specify any IP address and then / and any port. And that automatically establishes a TCP connection to that IP and port. And basically, when you read that file, it will read from that TCP connection. And when you write to that file, it will write to the TCP connection. So this is essentially says, start bash, redirect output into this file, and redirect input and standard input to get standard input from that file. Now, there's two things. So I took this command, the template from here. There's two things to pay attention. This should be the IP address of your attack box, and this should be a port number that you pick. It can be any port number, but essentially the target box needs to be able to connect to your box using that port number. So in practice, port 443 works really well because generally that's HTTPS, and generally HTTPS is often open outbound. But theoretically, you could use any port that is open. Now, this is the first part of that reverse shell. It's basically when we execute this pipeline, the target box, the runner, will run the shell, initiate that connection. Now we need to accept the connection so we can work with that reverse shell. And to do that, we're going to use a netcat. So it's dash. Okay, so what's happening here is netcat essentially allows you to make or accept network connections and then pipe them into commands or save them to files. So it's basically a fairly flexible thing to interact, do interaction over the network between different processes and different hosts. So what we're doing here is L stands for listen. So I'm basically telling netcat to listen, not initiate connection, but basically listen and accept connections. V means verbose, so it will basically tell me when it receives a connection. Otherwise, you might not see anything, even though connection might be established. So this is so that it's easier to realize when the connection was made. N stands for not resolving DNS names. So basically, when the connection is accepted, it will not try to like reverse look up the IP address that's trying to connect and do things like that. And P specifies the port number in this case, because we've used -L, it specifies the port number to listen on. So this number should be the same as this number, but other than that, the only requirement is that the target machine is able to go through firewall. The firewalls between target machine and your attack box allows that connection. So I'm gonna start that, and then I'm gonna commit this change and pray that everything works out. And we did get that connection back. I'm gonna pause for just a minute and let people catch up. So post when you got reverse shell, just post reverse shell or something like that, rev shell in the chat. And if you're having issues, also post and we'll help you out. Kalash is in, Tim is in. Okay, and while we do that, while we're waiting for people to catch up, I'm gonna search for another thing and show you a thing that's not required, but that's gonna be quite useful for us. And that is called upgrade reverse shell. Is this font okay, or do you need to make it bigger? You guys see this fine? This is quite small. Maybe I need to make it bigger. Okay, so who needs help? This is a critical part. It might be slightly easier afterwards. I'm going to pause just for 5 minutes so we can have bio break, and we'll allow people to catch up. Cheng, congratulations, you're there. So let's take 5. So if you've got reverse shell, just relax, stretch, and if not, then if you've got a question or have challenge, post that in chat and we'll help you. All right. So anything interesting anybody found in the container? Well, firstly, how do we know it's a container, by the way? I usually do just PS. There's only 4 processes, and process ID 1 is running bash, which is like on a normal Linux box, process number ID should be running init that bootstraps all the other processes on the machine when it boots. So this is definitely a container. So we did the env as part of the pipeline, but we can also run that here, and you can see that masking here obviously doesn't work. So as I said, this is more like a foolproof thing, foolproof control, so that you accidentally don't leak secrets. It doesn't actually protect your secrets if somebody has access to the project. Anything else interesting that anybody found? Do we have curl? We don't have curl. So one interesting thing might be LSB release. Forgot what that command was. LSB release. No. There's a neat little JWT bearer token. I'm not sure how important it is. Yeah, there is Talash. I think I couldn't find where it fits, but I think it's some sort of GitLab related credentials. So it's very similar to that default token that I was talking about, just maybe different sort of format that is used. So this container is based on Ubuntu. So we can use apt because we're like in the container, we are user root, so we can install packages. So we can do like apt install curl. So probably need apt update first. Apt install curl. Curl would be useful to have. And before we go any further, let's upgrade our shell. So what is upgrading a shell? So for example, if I press Control-C right now, that Control-C will be interpreted by my local shell on the attack box, which will mean it will terminate the netcat, and I will lose my connection. So if I accidentally run in this reverse shell, run a command that runs for a long time, and I want to stop it, and by virtue of habit, press Control-C, I'm going to lose that reverse shell. Not a good situation. Secondly, tab completion doesn't work. So you basically need to, like, if I know there's apt command, I type ap, press tab, and nothing happens. So if I want tab completion, if I want a better experience with the reverse shell, so those are the two things that essentially upgrading a reverse shell solves. So there's multiple ways. If we can find Python here, which Python 3, there's no Python or Python 3. Okay, so we're going to install Python 3 apt Python 3 no install recommend. I think that's the red flag. I mean, this shell is workable, but yeah, it's going to be easier to work with it once we upgrade the shell. So do we have Python? No. Nope. But we should have Python 3. Yeah. So okay. So this is a way to upgrade shell. So Python includes this PTY module, which is basically a terminal, pseudo terminal emulator, and it can be used as it is one of the methods to do this. So we do import PTY, and then we use PTY to spawn a new shell and do terminal emulation. So this is the first step. The second step is I'm going to press Control Z, and this will keep my netcat running, but I'll fall back into, oh God. Yeah, no, it's all good. So I'll fall back into my shell on the attack box. And what I'm going to do is type stty -echo. This disables local echo. And I'll enable raw. I think you don't need plus. Do you need plus? I don't think so. And then if I type something right now, I'm not going to see anything because I've disabled local echo. But what I'm going to do is I'm typing FG and enter, and I'm going to go get back into my netcat shell. And now I have a fully operational shell that has tab completion, will interpret Control C on the remote machine and not on the local machine. And so it's, yeah, as we talked about, it's nice, much better experience. Yeah, FG foreground. So because I press Control Z, it put the process into the background. So FG command basically brings it back into the foreground. Thanks, Mark. Okay. What else did we want to do? Now I'm a bit lost. Okay, curl. So we've got curl. So we know this is running in the AWS environment. So one of the interesting things to check in any sort of cloud environment is the metadata service. Metadata service basically is accessible from, or at least theoretically, if it's not blocked, it's accessible from any VM, any instance that's running in AWS. And this is a common way to inject any sort of credentials into the applications that run on EC2 instances. So from that perspective, that is an interesting thing to do. So metadata service is always running on this sort of fixed IP address, 169.254.169.254. And then there's latest, I think. And so what's happening, and we don't see any output, but let's add verbose flag to curl and see what's happening. So we're getting a 401 unauthorized response back. So we cannot access the metadata service from this container. I'll talk a little bit about why that's happening a little bit later on, but it's kind of important that at the moment from this container, there's no way for us to get to the metadata service, which from kind of security configuration perspective is a good thing. Okay, another thing that I would like to check, and by the way, if you found something interesting or you have an idea of what else we can check, post it in the chat as usual. But another thing that I would like to check is I'll run a mount command. And so remember, as we talked about that Docker containers and building Docker containers within the Docker containers, and that requiring access to the Docker API. So the way Docker works is Docker's API by default is exposed through a socket. So it's basically a special file that Docker daemon creates. And if you can open it and send commands through it, that's how you interact with the Docker daemon. And when I run mount, my suspicion is because of that comment is that the Docker socket would be mounted within this container so that you can run those build jobs in the container. And if we look at this within the output of that command, and or you can, if this is too much, you can do grep Docker. We see that that is the case. So we do have Docker container or Docker socket mounted within this container. What that means is if we have Docker CLI, we can interact with Docker daemon. And by the way, because this is Docker socket mounted from the host, this is going to be interaction with the Docker daemon that's running on the host. So that's my plan. I'm going to install Docker CLI. No. I'm doing this no install recommends. You might not need it, but what I found is that there's fairly limited space that you can use, like disk space that you can use in that container. So if you install too many tools, like for example, if you install Git, you might run out of space and not be able to install Docker. Okay, so now we have Docker. Yep, and one thing I'll run, I just want to confirm that we do have access to the Docker daemon. One of the ways to do that is run Docker version. Why this works is because it not only gives you a version of the local CLI that you're using, but it's also trying to connect to the Docker daemon and showing you the version of the Docker daemon if it was able to connect. So when I run this, we see the client version. This is the one that we just installed, and this is the server version, basically the version of the Docker daemon. So we are successfully connecting to the Docker daemon. Before we go any further, there's another thing that I would like to show you. And this is going back to those credentials that we talked about, the default credentials that are injected to the runner, default GitLab credentials. So if I go back here and go into that, I guess we can use this this repository as well. So if I grab the URL to clone this repository, now if I do just git clone, sorry, and I'll just change into temp. So the git clone and provide this URL. I won't be able to do this because I don't have credentials. So I could use that airman and the generated password, but what I wanted to show you is that the token that we found within the runner, if I can find it. So this is the username, GitLab CI token. So I'm going to try to use those credentials and see if it has access to GitLab, and show you that it does. So I was able to clone that repository, which basically tells me that those are valid credentials to access GitLab. They are short-lived, as we talked about, but because the pipeline is still running, and by the way, we can check it here, jobs, you will see that that job is still running, and that's because we have that reverse shell. It's basically like in that cycle that waits for input and executes commands. While the pipeline is still running, these credentials are valid, so you can use them potentially. All right, so we've checked that we have access to Docker daemon. We've installed the Docker CLI, and now what we're gonna do is I'm gonna show you why Docker documentation. And I don't know if somebody can find that link to Docker documentation that basically says that, but we'll use Docker to escalate our privileges and get access to the host. There's probably multiple ways of doing that. I think the way that I did it initially might be interesting, but let's try a different one. Okay. So I'm going to type this command and then I'm going to explain what it is. So we have, maybe I'll create a file. Show you. There's no nano. No VI. Okay. Maybe not. There we go. Okay, so I'm doing Docker run. This will start a new container. Don't need this. I actually need. I want to run it as -I means interactive. Basically saying I want to interact with that container when it starts. T means allocate sudo terminal. So again, it just makes things much easier to work with. --rm means delete the container once it's stopped. So once I exit from that shell, it's going to stop. Privileged means that I want to run privileged container. We're going to use that to basically escape from that container onto the host. And --pid equal host means that I use host's PID name process ID namespace for this container. So these two flags, it probably would take me too long to explain what they mean, but those are the two flags that allow us to escalate privileges. So the idea here is that we are starting a new container and giving them privileges that will allow us to jump from that container onto the host itself. So the three things that allow us to do that, one is this privilege flag, the second one is PID equals host, and the third one is this -v, which tells Docker daemon to mount the root of the file system, which is basically the whole of host's file system, as /hostos within the container. And the last parameter is Ubuntu, which is the image to use for that container. So you can use whatever you want. You can use Alpine or you can use Ubuntu. It doesn't really matter that much. We'll use Ubuntu, just cause. Okay, so now we're not in the runner anymore because we specified the -it. Now we're in the container that we have just started. And to show you, in the root of file system, we see that hostos mount, and you can check that it's there, hostos. Ooh. So this is that mount. And if I go into the hostos, this is basically the root file system on the host. So now what we need to do is escape this container and get onto the host. I'm gonna just quickly check chat. Yeah. Yeah, Mark, that is nuts, but that's exactly the reason why basically access to Docker daemon means privileged access to the host. And so as FYI, a lot of the container orchestration technologies, for example, allow like Kubernetes and Docker Swarm. Actually, I'm not sure about Docker Swarm, but definitely Kubernetes allow you to limit what sort of sensitive privileges you can assign to containers within the cluster. So I'll do two things. I'll do change root. Do I need to do this first? Well, actually, I don't need to do that first. So the second part of this magic that will allow us to now jump from this container onto the host. So the first part of magic was the privileged host PID namespace and the mounting of the root file system. The second piece of magic is this ns enter command. So again, I probably won't be able to explain it today, but essentially what Docker containers are, it's not a single concept within Linux, but it's essentially a combination of multiple things. One of the core of which is this idea of namespaces, which allows you to sort of create this pockets of isolation with regard to processes, user IDs, network access, et cetera, on the single host. So you can basically trick different processes into thinking that they're running in isolation or have different network configuration than others. And so what ns enter does, it allows you to, if you have permissions, it allows you to change a jump basically between namespaces. And that's exactly what we want to do, because now we're running in the namespace of this container, but we want to jump into all of the namespaces of the host. And that is basically will give us full access to the host itself. So what I'm doing here is --all means that I want to switch all of the namespaces, and --target1 says that I want to switch to namespaces of this target process, and target process 1 is the init process that basically has full access to the host. And then I'm adding this flag, which is basically saying, hey, before you do all of this, treat that /hostos as your root file system and then I need to specify the command to run with all these parameters. So now that I've done that, this new shell that I got is now on the host, and we can check that by running IP addr, IP address, and we can do ps and see all the process. So we're basically on the target machine. And because we started that container as root, which is the default setting within the Ubuntu image, now that we've switched the namespaces, we're also root on the host itself. Okay, so I'm gonna pause here. I'll do two things. Firstly, I'll post into chat those two commands that are executed so that people can catch up. So this was the first one. Again, the first one starts a new container with those privileged flags that will allow us later on to jump from that container onto the host to basically escape the containment, if you will. And the second command is the command that does that escape if those flags, the privileged and host PID and the root file system mount are present. All right. I'll cover a couple more things. Firstly, I wanted to show you that, so this was that new container that we started. It will also see all of the processes on the host, and this is the result of that --pid process ID equal host. This is what allows us to see the process ID 1 and kind of jump into it. The second part I'll show you is we're still in this container has still its own sort of network namespace. So it doesn't see all the networking that's happening on the host. So if I do IP address, it's not installed. Oh God. IPU hill. I can't even remember what package installs that stuff. Okay, so you can see this is a network that Docker daemon created for this container. So we're not seeing any of the network configuration of the host, but once we do that ns enter, ns enter stands for namespace enter. Now the IP address output is quite different. So we see the loopback, we see the actual network interface of that host with the internal IP address. We see the Docker bridge that Docker daemon uses for its networking with the containers. And we see those virtual network interfaces that have been created for different containers and whatnot. So essentially, this access is full access to the host. All right, and with that, I'm going to start a 5-minute timer, and I'll be checking chat. I've posted those commands, and post something like I'm root or something like that once you get to this point. Sure, Mark. What part are you interested in?
Oh, I recall, I think we installed Python 3, and there's a bunch of other steps prior to actually lighting up Docker.
Oh, I won't be able to pull up the terminal history. I can scroll back, but like this terminal is different from that terminal, so the history is not going to be here. I'll have to go way back. Oh, this was, I think, when we were decoding that base 64. Okay, where were we? Yeah, those are the packages that we installed, and you need to do app update before you'll be able to do that. By the way, if you borked your reverse shell and want to get a new one, you'll have to make a new commit so that the pipeline can run again. It doesn't matter what that commit is. You can add like a space to some command or to some string. It doesn't matter, but there actually might be a way to rerun the job. I'm not sure. Oh yeah, you can click here or something. Though that will rerun from that commit. Yeah, so like if I bork this TTY, this will be either passed or failed, and then I'll be able to rerun it like this. So maybe I'm wrong. Okay, so let's review what we've done. We've got reverse shell, and that's using the pentest monkey hints and plugging them into the CI/CD pipeline definition. We caught that reverse shell using netcat. In that reverse shell in the GitLab runner, we've installed curl just to check that metadata thing. You don't actually need it. Python 3 so that we can upgrade the shell using that Python 3 tips, wherever those were, this. And then we installed docker.io. Docker.io is basically Ubuntu's OS provided package that has Docker, and that gave us access to Docker CLI. And because the Docker socket is mounted, now we could start the containers. And then we started the new container that had those bunch of privileged settings enabled. And I've posted that command. And then we did ns-enter trick to jump onto the host. So by now you should be root on the host. And so we can look around here. The timer is done. So we can look around here, but what you will discover is this is the same, this is basically the target host. So the runner is executing on the same host where GitLab itself is installed as a Docker container. So if we go into opt, like we can check the running processes and see that there's Postgres instance of GitLab for GitLab. There's the GitLab processes, a bunch of them running, et cetera, et cetera. So first you can gather it from there, but you also can see that in opt, there's GitLab installed. All right, so now that we have all of this nice little access, what do we want to do next? Any thoughts, ideas? So one thing I'd like to do, and by the way, still think about ideas and post them into chat, but one thing I'd like to check is, do we have access to the metadata from the host itself? 169.254, 169.254, latest. Latest is basically a version of that, of the metadata API. And so this is interesting. And this is happening because in the configuration, these guys have something called IMDS v2 enabled. So if you want to read up on that, that's a I think, fairly important topic for cloud security. And something, if you're running a lot of, or if you work for a company that runs a lot of workloads in EC2 in AWS, this is definitely something to explore. That's basically a setting that, so with the metadata service, if you have any sort of SSRF issue within any of the workloads that you run, potentially somebody can use those and access the metadata service. And then if you have any AWS privileges assigned to those EC2 instances, those privileges can now be used by the attacker. So to deal with that, AWS has implemented what they call IMDS v2, which stands for Instance Metadata Service version 2. And version 2 essentially implements some of the protections against SSRF attacks against the metadata service. So what basically is happening is you can no longer just issue simple requests to the metadata service. You need to request a token first, and then you need to, the actual metadata request, you need to provide the token and also provide a special header. Otherwise, the metadata service will not respond. So all of that is a good thing, because if you have, even if you have SSRF, if you have IMDS v2 enabled on the instances, it's virtually impossible to use the SSRF and get access to AWS. But it's worth mentioning that IMDS v2 is not enabled by default, so you need to actually manually disable v1 and only leave with v2 if you want to protect your instances. So we're going to check this. I'll just search for IMDS v2. I'll just show you the commands that basically you can go through that token and whatnot. Oops, too much. Okay. Okay. I realize you don't see this, but basically this is the first step. This makes a curl put request to grab the token by using this URL, latest API token. And this request needs to have, it doesn't need to have, but you can also specify the time frame for which the token will be active. And then the second step is when you want to access the metadata itself, you need to provide that token within the header together with the request, and only then your request will be authorized. So now that we have this metadata, what we will check is the user data part of the metadata. So who knows what user data is in the context of AWS and actually DigitalOcean and a lot of the other cloud providers as well? Okay, come on, it cannot be just me talking all evening today. Mark, you must know this.
What was the question?
What is the user data?
The user data in what context?
In the context of AWS and EC2 instances and what you can get out of metadata.
Oh, you can get all of the goodness. You can get the API key. You can get the secret key. That's pretty well, I assume, where you're going.
Yeah, but also, so imagine you want to deploy some EC2 instances, but you also want to automate provisioning some of the software onto those instances. For example, you want, when you deploy an instance, you want it to install Nginx and grab some configuration for that Nginx and do things like that. So you can just easily spin up instances and they're all automatically provisioned with some configuration or some software that you're using, et cetera, et cetera. So one way of doing that is using this notion of user data, which essentially can include a bunch of commands like a script that will be executed once the first time the instance starts. So this is what I've just requested in the context of instance metadata. It's located under /user-data. So latest again is the version of the metadata, and then you do /user-data. And this output that I got, this is essentially the provisioning script for that EC2 instance. And so one way of solving this CTF is to look through this, and you will see that there's this GitLab root password that's leaked in that script, and you can actually use this password to log into that GitLab instance as root and basically get full access to GitLab. So let's try that first, but I'll show you a different method, which I think is the intended or better method, because you won't always get this nice surprise of passwords in the user data. So I've logged out from Airman, and I'm using root, and I'm using this password that I just grabbed out of this script. So this password is in this script just because the creators of the CTF automated the deployment of GitLab. If it wasn't for that, this wouldn't be here. And this is why I like the other method better. So now we're logged in as root, and you can see that we have access to a lot of other projects as well, including the Infra Deployer. Now, having said that, let's not forget that we have root access to this whole VM. And so what I did based on that is use a bit of Google foo. And I typed in GitLab command line reset root password. I think it's the first page that you can use. All right, before we go there, any questions? Anybody has challenges catching up? Or if you're okay with us continuing, maybe you can post okay into the chat. Please post your command to get the user data. Sure. So again, to get to this page, I've Googled IMDS-v2. That's all I did. So there's two commands. The first one gets the token. And so token is required to use the metadata service with IMDS-v2. So this is the first command. And the second command, once you got the token, you can use the, oops, what did I do? You can use the second command to grab the user data. So that's like that path in the second command. Basically, the second command is how you interact with the metadata service. And there's a lot of interesting things in the metadata service. That specific one just grabs the user data. By the way, it can be empty if whoever's running that instance is not using those provisioning scripts. There will be nothing in there. Yeah, and by the way, yeah, Mark, thank you. There's a walkthrough on the Hacking the Cloud website as part of the CTF, so you can grab the commands there. The second option that I'm going to use to get access to those keys is not covered in the walkthrough, so bear with me. Any other questions? All right, let's go ahead. So I just Googled GitLab command line reset root password. This is the first page that I got. So you can imagine having full access to the host. You can do a lot of things, including basically run recovery commands for GitLab. So imagine somebody forgot that password for the root user and you want to do something with that GitLab instance, there's got to be a way to do that. And so this is basically the page that talks about that. So what I'm going to do is see if we have that GitLab rake command available. GitLab, I'll do which GitLab rake. Yep. And so what we need to do, because we're already root, we'll run this. And this is essentially a command line, admin command line interface for GitLab. It's gonna take a little bit of time. I think that the reason for the amount of time that it takes is that GitLab is fairly resource intensive and that instance is not very powerful instance. So I think it's kind of lacking enough RAM basically. So now when I run this, it says enter username. So I can use root or I can use Mark, who is the owner of that project that we're interested in. Let's do root and I'll do let me in is the password. Let me in is the password. And now we've reset the GitLab root password. Now we can go back and log in. Let me in.
It didn't take the password, Amiran, because you need 8 characters.
Oh, God. I can't read today. What's wrong with let me in? Right?
Where shall I begin?
What was that? Lord of the Rings, say friend and enter something?
Yeah, that was on the doors to the mines of Moria.
Right, right. What do we do?
How's your Elvish?
Oh, it's great. I'll use password 123. How about that? Now it should be okay. Password 123. And we're in. We're basically a step away from our credentials. So we'll post this command into the chat. I'll also post this link if you want to take a look. You can also use this one, like you can provide the username in these brackets if you want to. Otherwise, it'll just ask about them. I'll post this link as well, just in case. All right, what else? Does anybody need to catch up or are we okay to go ahead? So post GitLab if you got root access to GitLab instance. To the application, not root access to the target machine, target host. Nice, Tim. Right. If we've got questions or you're stuck, post in chat. Otherwise, I'm going to continue and we're going to follow up with the questions if need be. Okay. So now I'm root. We're just going to go into that interesting Infra Deployer project and go into settings. So basically, I'm going into that section of the settings that we already saw for the other project that was empty. But now it's not empty, and we see that there's access key and there's secret key, and we can basically copy paste the values. Nice. I've been playing, as you can see, with Pop OS, which is a flavor of Linux created by, I think, System76 that makes Linux-based laptops, or Linux-optimized laptops, I should say. I quite like it, especially like you can get basically tiling window manager out of the box. It's really easy to configure and it's quite usable. But yeah, so we've got the keys. So now, last step that I'd like to do is I would like to try them, right? So do we have AWS CLI? Yeah, so we have AWS CLI installed on this machine. Dash version. There we go. It's version 1, but that doesn't really matter. So we'll grab this access key and we'll grab the secret key and plug them into the environment variables so that AWS CLI tools can use them. And then what we'll do is just check what user ID did we get. To do that, we're going to use STS, which stands for Secure Token Service. It has a API called Get Caller Identity that will basically tell you what user ID you have credentials for. And in this case, that's our target user, the AWS admin automation user. So we've reached our objective in this CTF. That was not intentional, Mark. Thank you. I had no idea how long this is going to take, and I didn't have a chance to do any sort of dry runs, so it's all a coincidence. My labs usually run way late.
Yeah, that was awesome. Definitely very insightful and a great CTF.
I love it. Yeah.
Relatively self-contained, and there's a lot of value that you can extract from this. And from a complexity perspective, I think, with some guidance, which you provided, you can definitely, bring an audience of varying technical competencies along.
Yep. Okay.
So, I've got a question for Sashimi, because she or he said that they could finally log in. So what was it, Sashimi, that got you into GitLab? They're not saying.
I guess not. Couple of things before we all jump off. Firstly, we're always looking for speakers. If you've got an interesting topic you're willing to present on, reach out, let me know. You can do that through Meetup. You can do that through Mars Slack. There's a DC604 channel there. Somehow reach out to me directly. You can reach me on Twitter. By the way, I'm just going to post Airman604. You can DM me on Twitter. As I said, we're always looking for speakers. Even if you have a good topic that you want to hear about, but you're not feeling comfortable presenting on, also let us know, because we will find people who are experts in that field, and it'll help us to shape the topics and shape the future meetups. But we're kind of struggling. We don't have anything lined up for June. We kind of have tentative workshop lined up for July. But unless community participates, this has a chance of basically falling apart. That's the first thing. The second thing is we're kind of thinking about, or gauging interest, I should say, about bringing back the in-person meetups, or maybe hybrid meetups with like part people joining in person if they want to, and others joining online if they're not comfortable or they're not located in Vancouver. So if you're interested in either way, or if you're like strongly opposing an in-person option, let us know. Again, Meetup, Mars Slack, and I'm going to post a link to how to join Mars Slack just in case you're not part of that. Or ping me on Twitter, or ping DefCon604 on Twitter. That's our official DefCon account. Or Planet Slack. There we go. So that's the link to join Mars Slack.
Thanks so much for doing that, Amiran. Great workshop.
Thank you. I'm happy that a lot of people joined and a lot of people followed along, at least to some extent, it seems like. And we've got Tim that it sounds like went all the way till the end. So good work, everybody. If there's questions, I'm happy to stick around for a bit. If not, have a great evening, and we hope to see you in June. And yeah, if you've got ideas about talks, if you can present, you're willing to. And by the way, if you're like a first-time speaker, we've got people who can mentor. Like we've done it multiple times. We had a number of first-time speakers in the last year or so. So it's not a big deal. Don't be shy. This is usually a fairly friendly group. Once we get past the initial idiots that try to join and ruin others' day. So the recording. Sorry, what, Mark?
Worth mentioning Terraform destroy.
Yeah, good point. Don't forget to destroy all of that stuff, because otherwise it's going to be running in your AWS account. If you've just deployed it and want to destroy it right away, there's not going to be a lot of charge. It's like literally a couple EC2 instances. But yeah, just make sure you don't keep them running. The recording, we're not sure yet. We're not 100% sure if the recording will be published. I think it went relatively well. Like we were concerned about basically the quality of the workshop. So there's probably a good chance that we will publish it. We usually publish it on our YouTube channel. Kevin, if you have a chance, can you post the link? And we've got some of the past meetups, recordings from the past meetups in there as well, if you want to check them out. There's several where we had really interesting conversations and topics and speakers and whatnot. So last month, if you joined for our AWS security workshop, that recording will not be posted based on just input from one of our speakers, but generally we try to post the recordings. Yep, thanks, Kevin. So that's the link to the DC604 YouTube channel. And I think we will post the recording, and if we do, that's where it's going to be posted in maybe 2-3 weeks or so, once we have a chance to process it a bit and add some niceties. All right, and with that, thanks everyone for joining. Have a good night and hope to see you soon.
Thank you. Have a great night.
You too. Cheers.
Cheers.